Good morning. I Dr. Navina Priyadarshini, Professor of EC Department, Rohini College of Engineering and Technology. Today's class, we shall discuss about the Shannon's channel capacity theorem. So, Shannon's channel capacity theorem, it states that the amount of the capacity of the channel through which it can allow the data to be transmitted for successful transmission. So this channel coding theorem is mainly applicable in noisy channel conditions. So here this channel coding theorem is also known as Shannon's theorem. So it establishes that for any given degrees of noise contamination of a communication channel, it is possible to communicate discrete data nearly error-free up to a computable maximum rate through the channel. So we can say that in a noisy environment, how the channel we can transmit the data through the channel with maximum quality. So here the theorem describes the maximum possible efficiency of error correcting methods versus the level of noise interference and data corruption. So Shannon's theorem has wide-ranging applications in both communication as well as data storage. This theorem is foundational importance to the modern field of information theory. So here the proof of is given as outline. So Shannon's theorem states that in a given a noisy channel let us consider the channel capacity is capital C and the information rate that is transmitted through the channel is considered to be capital R, then the rate into capacity, that is an arbitrarily the product of rate and capacity RC is an arbitrarily small probability of error which is not achievable. So all the codes have a probability of error greater than a certain positive minimum level, and this level increases as the rate increases. So information cannot be guaranteed to be transmitted reliably across a channel at rates beyond the channel capacity. So for a channel which has a particular capacity and we are transmitting the data, so the data rate of the channel that should be less than or equal to the channel capacity. So if the data rate is smaller than the channel capacity, the channel will support a successful transmission of data. And if the capacity of the channel is smaller than the bandwidth as well as the rate of the channel, then we cannot expect a perfect transmission through the channel. There may be chances for addition of noise and the amount of data will be get lost during transmission. So here this theorem does not address the rate situation in which the rate and capacity are equal. So the channel capacity C can be calculated from the physical properties of the channel for a band limited channel with Gaussian noise using the Shannon-Hartley theorem. Here the spectral efficiency and the relation between the spectral efficiency and the SNR is given. So SNR states that it's the ratio of signal to noise ratio. So for a perfect communication, the signal rate should be higher than the noise power. So if the signal power is greater than the noise power, we can receive the signal with good quality, and if the noise power is get increased, the performance of the quality of the channel is get degraded. Spectral efficiency, which defined as this efficient utilization of the spectrum. So within the allocated bandwidth, how the spectrum is efficiently utilized. That is, so here the relationship between the spectral efficiency and SNR is given. So in general, the capacity of the system is based on the Shannon's theorem. Capacity C is defined as B into log of 1 plus S by N, where 1 by S by N is the signal to noise ratio. B indicates the bandwidth of the channel. So we can say that um, in terms of decibel, it is given as B log of 1 plus SNR to the base 10 divided by log of 2 to the base 10. So here you can say that the channel capacity and the power efficiency limits. So if the rate of the channel is greater than the capacity, so it is indicated in red line. So that is unattainable. So if the rate of the channel should be less than the capacity of the channel. So the second case is the practical system where the rate of the channel is less than the capacity. So that condition is achievable. And if the rate of the channel is equal to the capacity, a perfect linear improvement in this curve is obtained. So the curve is exponentially increasing. So here the theorem states that the channel capacity, meaning the theoretical rate, just upper bound on the information rate of a clean data that has been sent with the given average signal power of S through an analog communication channel in the presence of additive Gaussian noise, which is given as channel capacity C is equal to B log of 1 plus SNR to the base 2. So here C is the capacity of the channel, B is the bandwidth of the channel, units is in hertz, and S is the average received power over the bandwidth, and N is the average noise power or interference power in watts, and this by N is the signal to noise ratio in the presence of the Gaussian noise environment. So by using the channel capacity expression, this capacity of the system is identified. So we can conclude that the channel capacity for efficient communication system, the channel capacity should be, or the data rate should be less than the channel capacity. Thank you.